have our next speaker now here, Jan-Philipp. He's the founder and CEO of the company called Davis. They just changed their name 2 weeks ago, so I think in our program we all saw the name Hashplay. And they're one of the leading real-world analytics platform. I think you founded it around 5 years ago, 4.5, 5 years ago. And there are two big topics they're talking about, or they're using it for, and one is retail, and the other one is healthcare. Both, I think, very good, interesting topics to use such a topic for. And what I thought was really interesting as well, that years before you had another platform called That's My Wine, a customer taste profile solution. I think that is more, for my thing, a really interesting thing as well, like taking wine into this whole topic. And he's here today talking about real-world analytics, and that's your 12 minutes.
Hi. Thank you very much for being here. Yeah, real-world analytics. As she already rightfully said, we changed our name 2 weeks ago, and essentially we kind of grew up. Hashplay started 2015 as a game streaming company, and over that last 4.5 to 5 years, we more and more simplified and specified our value proposition towards our customers. We pivoted end of 2015 from a game streaming company towards more an enterprise-related solution, allowed other people to create VR environments. Essentially, we're still using VR, but from a completely different perspective. So yeah, real-world analytics. So essentially, we turn the world into attributes of interest. So we, instead of doing facial recognition, we look around, and a lot of people know these kind of spaces, especially in urban areas. And in order to understand that situation, current solutions kind of just do counting, and they're very bad at that, essentially. And you don't really understand in... Clicker doesn't work. Technology. In rooms like that, what is actually going on these underground stations, for example. So, so we thought, or actually Airbus initially, and then the Messe Berlin, where our solution is deployed, approached us and said, can't you build us a digital twin of what is going on in our trade show and event area? So it's now operational. We are doing real-time analysis of 180,000 square meters in the city center of Berlin. Not just using cameras, but mainly using cameras. And you know, in these rooms, you don't really see anything. The counting part, maybe you can show some counts, but you don't really understand context of the actual situation. And it's not really shareable due to all the privacy regulations, which were probably mentioned a couple of times today. GDPR is one issue, union compliance, labor laws. So there are a lot of issues, not just in Germany, but in Europe overall. So essentially, you need a superpower. And that superpower allows you to not just count, but classify what is going on without infringing privacy, without really going towards the actual person, but going towards the attribute around the person. Maybe you want to know whether it's a female being, or the people in the room, maybe in a retail space, you want to adjust the marketing based on, at a certain period of time in a day, there are mainly females in the shopping center. So you want to adjust the marketing towards that. Or in a hospital, maybe you want to understand the actual operation. So for that purpose, we're using that concept of attributes of interest. Come on. Okay, so yeah, as I said, we do have customers like Airbus, Deutsche Messe, Messe Berlin. We've done some stuff for KPMG, and we're now being integrated by T-Systems. So they're actually scaling us globally now, since a couple of weeks. And we've deployed our solution in the Vincenz group in Hanover. So we are now doing real-time surveillance, essentially, of a hospital. But we're not doing real-time surveillance, we're doing real-time monitoring, which is a huge difference. And I will show you an example. Technology. Okay, so basically, that would be normal surveillance camera footage, and our solution turns it into a non-returnable, so we don't save any data. We essentially don't record anything whatsoever apart from the actual insights happening. So in a shopping center, we would know whether you have a bag or whether you dropped a bag. So there are certain security aspects to that too, but I will come to that at a later stage. Essentially, safety vests, are you wearing safety vests? You don't need to see the footage to understand whether your employees are wearing actually safety vests. So we're turning the footage into a more or less real-time game, and it's not reproducible. And also, we have developed algorithms. A lot of people are trying, so if you are looking at that kind of footage, it's very hard to localize without triangulation where the people are. So we've created a mathematical formula which allows us to create so-called spatial context of that using a single frame. I still got time, cool. So spatial context. So whatever our cameras see, we know where that is. And with additional formulas, we can turn that into geospatial context. So as we know, if we know where the camera is, we know where the exact location of that object is. And at a very, very high accuracy. So our key capabilities include counting, anonymization, classification, geospatial context. We can obviously time things if it's according and within the law, where there are a lot of limitations. We can measure very, very, very accurately. We can filter and we can visualize in context. This is Messe Berlin. That's one of their dashboards. There are 3D dashboards, there are 2D dashboards. Depending on the actual use case, there are sometimes just apps at the gates to understand intra-logistical protocols. So we looked for a term, kind of, describing what we actually do. So we kind of turn this operation or hospital operation into so-called intra-logistical protocols. So whether you are moving bats within your operation, whether you're moving trash, whether you really want to understand how many trucks are on the ground and where they're moving, why they're moving, are they permitted to move, are they within that time frame which is allowed to move, because they usually have to pay $200 or 200 euros to get onto these grounds. So there are a lot of operational requirements around that to understand. And at the moment, they need to use a lot of people to check that, and they basically can't do it because it's so stressy, essentially. So we enable them to be more efficient. So measurement accuracy, as I said. So from a 25-meter difference, we are down to 1.5 centimeters in accuracy. So we can really do very accurate measurements based on a normal HD camera. So we don't need crazy equipment. We can just hang a camera somewhere and then understand what is going on around it. So first use case, Darvis for healthcare, as I said. So continuous improvement, and as I said, we are deployed in Vincenz in Hanover. So it's all about continuous and anonymous optimization of processes. Understand these processes, optimize them accordingly, and then take data points. So there are a lot of solutions who kind of go around it. So there are a lot of beacon solutions, there are a lot of other solutions, but what we learned is if you add a new device, you need to add a new beacon, or you need to add a new thing to it so that it works. Or if you want to have smaller devices where it may make sense to track them, you can easily do that by training our AI instead of having to add additional devices. Obviously, there's RFID and other things, but you always need these patches. You have got QR codes, but you always need them to be seen by the cameras. So what we have come up with is a classification methodology to track within the hospital bats. So we're not tracking the people, which is very, very, very essential. So when you've got a normal hospital operation, one of them is bad logistics, as I said. So there is a hygiene component to that, very strong one. And there's a utilization or an inventory tracking component to that. So there are a lot of devices which are not part of any platform. There are major people like Philips and GE who are supplying devices in this landscape. But they don't really talk that much to each other, essentially, because it's not their interest. So essentially, you really, or at least the hospital operators we have talked to, they kind of want to get a hold of their data themselves again, number one. Secondly, they want to understand where the beds are, because there are a lot of delays in hospitals. Everybody who's been in a hospital knows it takes time, and it doesn't take time going there. So they're very good at giving you a meeting time or an appointment time. They just send you an SMS or an email or whatever. But they're very bad once you're in there. So, because they are not really allowed to track you. So what we've come up with, essentially, we classify a nurse. Yes, we do. But there are a lot of nurses in the hospital. We classify beds. We classify time it's taking towards the destination. Absolutely. So that the transporter who's doing the actual transportation, and in a lot of hospitals there are actually external services doing that circulation, so it's not just the nurses. So that the nurses can concentrate on patient time, which is more essential than transporting beds. And one more thing, and I still got a bit of time, cool. Once we have that cameras in there, we can do a lot of cool things, like hygiene tracking. So we can understand where it has been cleaned. Because I don't know if you've heard about hospitals being in trouble because there are a lot of bugs in there, or hospital bugs, essentially. So a lot of that has to do with protocols and really tracking protocols within it. So, and understanding whether somebody has cleaned their hands and or somebody has actually cleaned stuff. We create that heat map so we know whether the room has been cleaned. So the patient can understand whether he's sitting in a clean room, which is an added value. As I said, it's not about tracking the individual person. It's about giving nurses the possibility to understand whether they're working in a safe environment. Same in the surgery rooms, essentially, and we can track a lot more things there, but we're concentrating not being a medical product, we are a process product. We train our AI not based on footage, which is a very large differentiator. We train it based on VR. So we basically create the hospital in real time before. So we play a computer game, but very, 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 very realistic. So we don't have to look at everybody being in a hospital. We can just pre-structure these phases. We can pre-learn everything. Thank you very much.
Thank you. Yeah, they're already, I don't have, you know how the game is going. We have some questions.
Cool.
Hey JP, we like to discuss time to time, and you know I'm into like this sustainability thing because and I like your products. It's fascinating me all the time. But how does the measurement integrate like the different aspects of human beings? Like of course one person I can sprint faster than you, for example, with the bed if I'm really in a good mood, and another person takes a little bit longer. So how do you integrate all the different factors of time? Because if you have to say like this is one thing I don't like in the medical industry, like you have like one disease takes 2 days and that time is then 3 minutes, and there of course are differences.
Okay, yeah, so basically we don't care about the actual people performance because we're not allowed to, but we care about the bed performance, which is a completely different thing. So we don't care which employee pushes the bed if it's not a critical patient, because there are a lot of documentation requirements around that. So doctors have to accommodate certain patients if they're in critical condition. So we could eventually create another ILP or another intralogistical protocol to monitor whether a doctor has actually accommodated the patient, or whether there is need for additional staff, which is also very relevant. So at the moment, they just, at least the nurses in one of the hospitals, they just leave 5 beds lying, like being on the station, essentially, on the ward. And then they call the transporters, and then all transporters go there. So there are 5 on the shift, so the whole hospital stops, which is absolutely crazy. So, so that we're basically optimizing.
What would you say are typical use cases in terms of retail and healthcare? What are the metrics you would measure there for a typical use case? And do you also have the possibility to simulate and thereby optimize the processes and show it to your customers?
Yeah, of course. Yeah, so basically for retail, there are a lot of flow type of use cases. So understanding patterns of certain people. So when a lot of current shopping centers use Wi-Fi to track people, which works, but you don't know who that person is. You really don't. Since Apple shielded their IDs, you really don't. So, but you don't have to infringe their privacy by understanding it's a around 40-year-old female going shopping at a certain time. That doesn't infringe your privacy. We don't do more than a self-driving car. So no customer is going to see the actual footage, or nobody in the organization is going to see the actual footage. So we don't allow them to have the so-called screen to or camera to screen concept. So you can't really see. You can only see in a gamified or dashboard type of environment. So, and yeah, as I said, we delete. So we do count, as I said, we do have a list of all sorts of KPIs, which I can show you, in terms of retail, in terms of healthcare. And there's also some security aspects, which we are now embedding in American schools against the school shootings.
Where do you see the biggest potential within the healthcare area for process optimization, from your point of view right now?
First of all, creating visibility. I think the first step is visibility. Actual understanding these processes. So there are a lot of algorithms we found and a lot of processes which go way around the problem because of these privacy issues, which I think is absolutely crazy. Because you should look at the problem and then solve it. Because the nurses are very busy in these places. So they really want help if you talk to them. So we went through the Betriebsrat, or the Union Labor Board. It took us about multiple legal opinions and a certification, which is now happening, to really prove to them that we don't care about them as a person. We care about them being more efficient in their job, and therefore they do have more patient time, essentially. And they really like it because they can add an automation. They can switch on an automation in order to pick up beds. And I think a second tab would be utilization of devices. A third would be probably maybe hygiene, very much, because it's a very, very pressing issue in a lot of countries. And then maybe documentation at some point.
Thank you very much for the introduction. I appreciate that. Is that service that you're providing, is it cloud-based or on-premise?
Both. So in a hospital, we actually deployed on site. And in Berlin, we also deployed on site. In America, in the schools, we are deployed in the cloud. Because they don't have the funds available to actually create infrastructure there. And we can also be deployed on the edge, depending on the requirement of the data model. So depending on the classification in itself. So what are we looking at, and what kind of problem are we looking at? Thank you very much.